Before watching this video, please subscribe this channel and click on bell icon to get the notifications for the upcoming classes.
So dry and saturated steam enters the nozzle at 10 bar pressure and expands isentropically to 1 bar pressure. Determine the following: quantity of steam at exit and exit velocity. So what is given here is dry saturated steam enters the nozzle at 10 bar. So this is the nozzle entrance and exit. So at entrance pressure is 10 bar. So P1 is 10 bar. At the exit P2 is 1 bar. So this is given data. Next, determine the following: quantity of steam, quality of the steam at exit and exit velocity. So at entry, dry saturated, quality of the steam is dry saturated. So x1 is 1. So x2 means dryness fraction. Dryness fraction is 1 at entry, and at exit you have to find. Next, exit velocity. So velocity at exit, when you assume that at entry velocity is negligible. Now to solve this problem, we should know the following data. So from steam tables we obtain the following data. At 10 bar and 1 bar, Tg for 10 bar is 179.9 degrees centigrade, 2.138 kilojoule per kg Kelvin, SF value. Entropy, Sg value 6.583. So entropy at a dry saturated line. HF 762.6 and all these values. So we can see these values from steam tables or from textbook. The textbook, at the end, so saturated water and steam tables, so absolute pressure in bars, temperature in degrees centigrade, specific volume, specific entropy, specific enthalpy, and specific entropy. So we want to know at 1 bar and 10 bar what are these values. So at 1 bar, so the pressure here is in bars. Pressure is in bars. So 1 bar, Tg value is 99.63. So Tg value is 99.63. Similarly, SF value is this 1.303. Sg value 7.36. HF value 417.5. HFG 2257.9. Hg 2675.4. Similarly, at 10 bar also you are having all the values. So we can use this textbook or steam tables book. So this is steam tables book. So in this, at the entrance you have property of steams in MKS units, but our units are SI units. So SI units, so dry saturated steam based on pressure. You have to see them based on pressure, that is 36 to 41 page. So 36 property of saturated steam pressure basis. So pressure is in bars. So our pressure is 1 bar. So at 1 bar pressure in bar and 1. So the temperature is 99.6. 99.6. SF value is 1.303. Sg value is 7.5. 36. Next, HF value is 417.5. HFG value and HG values. So you can either use textbook or you can use Steam tables book. So after obtaining the table, we know that as the expansion is isentropic, here the expansion is isentropic, here the nozzle is insulated. Okay, so if you want to draw HS diagram for steam nozzle, H on the y-axis and S on the x-axis, this is saturation line. Okay, point 1 will be somewhere on the saturation line because it's dry saturated steam. So point 1 will be here, say it is at this point. So point 2 will be at the bottom, straight line, because the expansion is isentropic expansion. So point 2 will be wet steam. It has to be wet steam. So from this knowledge, as expansion is isentropic, expansion 1 to 2, S1 equal to S2, S1 equal to S2. The line is vertical. So as the expansion is isentropic, entropy before expansion is equal to entropy after expansion. S1 is equal to S2. This is S2. The S2 value when it is when the steam is wet steam, this is the value of S2. SF 2 plus X into HFG2 by TG2. S1, what is the value of S1? S1 means SG because it is on dry saturated line. So its value is SG value directly. So 6.583, that is equal to 1.303. How do you get 1.303? This is 1.303 plus x2 into HFG2. So HFG at 0.2. What is 0.2? 1 is so 1 is 0.2 because 0.2 is 1 bar. So 2257.9 divided by Tg2. So how do you get this value? This value you obtain, you have to convert this into Kelvin units. 99.63 plus 273. So what is this value? 0.63. So 372.63 Kelvin. So x2 is equal to, so if you solve this, x2 you will get as 0.87. So what does this mean? The dryness fraction at x2 is 0.87. It is 0.87. So hence the quality of steam at exit is 0.87 dry. Next, this is first part. What is the first A bit? To find quality of the steam at exit. Exit means 0.2. 0.2 pressure is 1 bar. Next, second question is to find exit velocity. We are having direct formula for finding out exit velocity. So H2 is equal to enthalpy of steam at pressure of 1 bar and 0.87. Because this is second point. Second point, that is exit. The conditions are pressure 1 bar and 0.87 dry. So what is the value of H2? H2 for wet steam. This is the formula for wet steam. HF2 plus X2 into HFG2. Next, exit velocity 44.72 into square root of H1 minus H2. So this is the answer. Okay. Next, second problem. So this is the second problem. So steam at 15 bar and 300 degrees centigrade expand in a nozzle to a pressure of 1 bar. If the efficiency of the nozzle is 88%, calculate the mass of steam discharge when the exit area is 180 mm square. Here again, if you draw nozzle, this is the nozzle. Section 1, section 2. So it's section 1. What is pressure? 15 bar. What is temperature? 300 degrees centigrade. Expands in a nozzle to a pressure of, so P2 is 1 bar. The efficiency of the nozzle is 88%. Calculate the mass of steam discharged when the exit area is 180 mm square. This area, cross section area, A2 is 180 mm square. This is given. So again, given data, we'll see initial pressure is 15 bar and corresponding temperature is 300 degrees centigrade. P2 1 bar, exit area 180 mm square. So 180 mm square is means 180 into 10 power minus 6. So this is the area because we have to substitute in meters. Next, nozzle efficiency is 88%. 88%. The nozzle efficiency 88% means friction factor K is 0.88. Okay, we have to substitute this 88% as friction factor K and its value is 0.88. Now we have two methods to solve this. One method is from Mollier diagram. Second method by using steam tables. We'll see both of them. So this is the HS diagram. So this is saturation line. Steam is 15 bar and 300 degrees centigrade. This is super saturated. If we look into the Mollier diagram, we'll find this point as super saturated. So 15 bar and 300 degrees centigrade expand to a nozzle to a pressure 1 bar. So 1 bar. So we can see this point again in the Mollier diagram as a wet steam. Okay. So 1 to 2 is the line when it is insulated. That is entropy is same at 1 and 2, isentropic process. If it is isentropic process 1 and 2, this is the line, but in the question it is given as that it is not isentropic process. It is process 1 to 2 dash. 1 to 2 dash. Okay, there are some frictional losses. So H1 minus H2, this is, suppose this is H1 minus H2. Then what is the second point? How do you get second point? To find second point, if you draw a line here, K into H1 minus H2. So starting point is same, H1 for both of them, but H2 dash, how do you get H2 dash? H1 minus H2 is this length, K into H1 minus H2. So from this you can find H2 dash. Okay, anyway, from Mollier diagram we'll see how to solve the problem. So steam table at the end. So this is Mollier diagram. Okay, and in SI units, our units are SI units. SI units. Okay, so this is saturated line, dry saturated line. This line is dry saturated line. So we can see these lines, dark lines. These are dryness fraction lines. So dryness fraction at this point is 0.85. At this line is 0.9. So 0.85 to 0.9, there are 4 lines in between. So this is 0.86, 0.87, 0.88, 0.89, 0.90. So there are so this is how the lines are. So these are lines are dryness fraction lines. Next, constant pressure lines. These lines are constant pressure lines, and the value of pressure is 0.1 bars. Okay, 0.1 bar because it's a SI unit. Here we can see 0.01 bar, 0.02, 0.03, so 0.1, 0.2. So our pressure is here. This is 15 bar, 15 bar. This line, pressure line, 15 bar, and it extends like this. Pressure bar, pressure lines. 5. It extends like this. So pressure lines. Next, temperature lines. 150 degrees centigrade line, 150 degrees, 200 degrees centigrade line. Okay, these are next. These and you are having specific enthalpy H, specific enthalpy H and S, HS diagram. This is HS diagram. It is a graph between enthalpy and entropy. Enthalpy on y-axis, entropy on x-axis. And these lines, dotted lines 0.75, this dotted line. So this dotted line, if you see, it is written here as 2. Okay, this dotted line is Vg value, that is specific volume meter cube per kg, 2 meter cube per kg, 1 meter cube per kg. Here you can see constant specific volume lines, 5 meter cube per kg. So 1, 2, 0.5, 0.2, like this specific volume lines. So now we'll see how to use this Mollier diagram. So our first value is P1 15 bar, and our first point value is 15 bar and 300 degrees centigrade. 15 bar and 300 degrees centigrade. So 15 bar, where is 15 bar line? This is 15 bar line. Okay, 12, next to 15. So if you see like this, okay, this is 15 bar line and 300 degrees centigrade. So 15 bar line and 300 degrees centigrade meet at this point. So this is super saturated line. If the point is anywhere on this, it is dry saturated line. Here it is super saturated line. Next, if you see second point 2, okay, if you draw a straight line, if you are assuming it as a isentropic process, if you are drawing straight line, second pressure value is second, that is at the exit we are having only one parameter, that is pressure. It is 1 bar. First point 15 bar and corresponding temperature 300 degrees centigrade. Here for second point you are having only 1 bar pressure. Okay, so 300 and corresponding pressure 15. If you draw a straight line, it meets this one. This is 1 bar. 1 bar curve at this point. So this is wet steam, superheated steam and wet steam. Okay, now how do you find these values? To solve this problem using Mollier diagram, we should know H1, H2, okay, and X2 dash value. So first you have to find H1, H2. How do you find H1 and H2? So first parameter, it is 300 degrees centigrade and 15 bar. 300 degrees centigrade and 15 bar. So 15 bar line and 300 degrees centigrade meet at this point. Okay. So if you plot this point and see here, it meet at this point. Okay, at this point. So this point 3000, it is between 3000 and 3100 kilojoule per kg. 3000 and 3100 kilojoule per kg. So what is this value exactly you have to find? So for finding this, so you should know how many lines are between 3000 and 3100. So if we count, there are 18 lines, and from the bottom if you count this, so 6, 7, 8, not this is not the point, this is the point, this is the point, 6th, 7th point. If you see from here, you'll get 7th point is the point. Okay, and its value, what is the value? How do you find the value? So bottom value is 3000, so h1, how do you get 3000 plus the total number of lines are 18. From here if you go, it's 7th line into 100. Okay, exactly from the scale you are finding the value from the scale. So 7 by 18 into 100. If you find that value, you will get 3039. Similar h2. Again, how do you find h2 value? Okay. This is 300 and this is the point. You have 315. So approximate value you can find it out. How? You draw a line where the pressure is 1 bar. So at this point, if you draw horizontal line, okay, if you draw horizontal line, you will see what is the value. So somewhere here. So here there are totally 19 lines. So out of 19, so this is the value. So 19, total there are 19 lines. So fourth line from bottom you are getting fourth line. Okay, so this into difference 100 plus 2500. So 2500 plus 4 by 19. 4 by 19 into 100. So you'll get 2521. So next, how do you get x2 value? So we have drawn a line like this. Okay, it meets 1 at this point. So this point, this is 1, and we draw straight line from this point. It meets at this point. This point is this point. If you go like this, it is 0.9, 0.93, 0.95. This is 0.93. So x2 is approximately equal to 0.93. x2 is approximately equal to 0.93. How do you are getting 0.93? You are projecting from 1 to the bottom, and you'll see the point where this 1 bar meet this line. So that point is x is equal to 0.93. x2 is equal to 0.93 approximately. So you're having the value of h1, h2, h1 from the graph, h2 from Mollier diagram. Next, x2 value also you're having approximately. Now x2 dash. So you have to find now 2 dash point. So how do you find 2 dash? So here you're having h1 minus h2 dash is equal to h1 minus h2 into 0.88. h1 minus h2 into k is nothing but h1 minus h2 dash. This value is equal to h1 minus h2 dash. h1 minus h2 dash is equal to k into h1 minus h2. So using this, you are finding out h2 dash. h2 dash is 2573.48 kilojoule per kg. So this is h2 dash. h2 dash, h2 dash. So once you get h2 dash, okay, so h2 and h2 dash will be on same pressure lines. h2 and h2 dash will be on the same pressure lines. P is equal to 1 bar. So you have to plot this h2 dash. So after getting h1, somewhere here you have to plot h2 dash. Okay, somewhere you will get somewhere here h2 dash based on this value, based on 2573.48. So 2573.48 approximately. You plot this point and draw horizontal line through this and see where it meets pressure 1 bar. So first you have to plot this value. Okay, what is that value? 2573, 2500, 2600, somewhere the value will be. So from there you draw a horizontal line and see where 1 bar pressure meets. So that is the point of h2 dash. So once you get h2 dash, okay, find x2 dash. x2 dash, how will you find? So x2 dash will be between two lines. Okay, so using that you find approximately, you find x2 dash. So x2 dash I found it to be 0.952. okay, so this is the value of x2 dash. So from Mollier diagram you can also find v2 directly. So v2 value is 0.6, 1.6. So 1.6 I find this value. How I find out this? Like this. So here you are having one dotted line, 1 meter cube per kg specific volume, here 2 meter cube per kg. So this is if you see this, it's coming like this. Okay, so this value is in between these two, and it is at a distance approximately in between value, and it is 1.6. okay, so how do you get 1.6? Measure the distance between both of them, and based on that you can find what is the value of specific volume. So if you try, you will get this. Now next, so you are getting v2 specific volume as 1.6 directly. Okay, now exit velocity v2 is 44.72 into square root of k h1 minus h2. So if you substitute this, you will get the value of v2. So what is v2? v2 is the exit velocity. From continuity equation, m is equal to a2 v2 by x2 dash vg2. Okay, so what is our question? Our question is to calculate the mass of the steam discharged when the exit area is 180 mm square. So you have to find mass of the steam. So finding out the mass of the steam, this is the equation. M is equal to a2 v2 by a2 area, v2 velocity at the exit, by x2 dash, okay, x2 dash, and vg2. So x2 dash and vg2, this point, because this is the actual line. Actually this is ideal line. 1 to 2 is ideal line. It's not our line, practically line. 1 to 2 dash, this is the actual process taking line. So a2 v2 by x2 dash vg2. So x2 dash vg2, you also call this as v2. So now substitute this value. 0.18 into 10 power minus 3. How you are getting this value? So this is the area, 0.18 into 10 power minus 3 meter square. 0.18 into 10 power minus 3 into 954 divided by 1.6 specific volume. So 1.60. Substitute, you will get 0.1073. So if you cannot find this value V2, if you cannot find this value V2, if you are finding out difficulty, so you can find V2, which is equal to x2 dash Vg2. So Vg2 you can find from the steam tables. When P2 is 1 bar, okay, Vg2 is 1.6937 meter cube per kg. So V2 is equal to x2 dash into Vg2, 0.952, which is equal to x2 dash. So x2 dash, x2, all these are approximate values. Okay, Vg2 is 1.6937. So this is V2. You can either find directly from the Mollier diagram or you can calculate like this. So this is the mass of the steam discharged, okay, using Mollier diagram. This is first method. Next, without using Mollier diagram and by using steam tables, okay, we'll see how to solve the same problem. So now using steam tables. So P1 is 15 bar. Okay, this is the question. So question, this and continuation is here. So 15 bar, 300 degrees centigrade. From steam tables you are getting H1 is equal to 3038.9 kilojoule per kg. So what is the value of P1? P2 is 1 bar. So if the nozzle is frictionless, again you have to remember this diagram. Okay, if you have to find H2. H2 is not actual value, practical value. But if the nozzle is frictionless, that is neglecting friction, S1 equal to S2. So S1 and S2 value. Okay, S2 is wet steam. So if you substitute all the values, you will get X2 as 0.927. Okay, this X2 value as 0.927. Now H2, after getting X2, you have to find H2 value. What is the value of H2? HF plus X into HF G2. So you are getting H2 value. From steam tables, P2 is equal to 1 bar and Vg2 1.6937 meter cube per kg. So you are getting these two values again from steam tables. So exit velocity V2 is, this is the formula. You are getting the exit velocity is 964.32 meter per second. But our practical value is not H2. It is H2 dash. Practical value is H2 dash. We have to take into account friction. Okay. So H1 minus H2 dash is equal to K times H1 minus H2. Okay. So 0.88 into 3038.9. So 2510.
Thank you for watching this video. Please subscribe this channel and click on bell icon to get the notifications for the upcoming classes. And share this